Well, good afternoon. So my name is Wenyu from NTT Communications. So actually, this is my third time to join this event and give a presentation on the stage in this event. I can still remember that the first time I did the presentation here, I shared with the audience our learnings and challenges in the live deployment of SD-WAN. That's all about SDN things. And last year, I actually shared with the audience our update on the NFV. We actually developed an NFV platform to provide different kind of NFV service, such as WAN optimization as a service, SD-WAN gateway as a service, and firewall as a service, to running on NFV, the platform that we developed so far. Well, that's about NFV. So 1 year passed. Today, I would like to share with you another update. So a new journey that starting from SDX and NFV, but it will go far beyond SDX and NFV. We call it SmartX. So that will be the topic that I would like to share with you today. Right. Anybody tell me how to use this machine? I see. So before we begin with, I would like to share with you some, the history. So when we start the journey of SDX and VXF. So the first journey starts actually 6 or 7 years ago. In order to pursue automation of network configuration, dynamic network management, we introduced open flow technology 6 and 7 years ago into our first public cloud service. So after that, green button, yeah, I pressed the green button. I just don't know where to, see, too slow. So after that, actually, the scope of the SDN expanded a lot. It expanded to the inter-DC network, which includes the cloud, which includes the network between the cloud and on-premise, the network that connects cloud and colocation space, and even the networks that connects the clouds. So that's a huge jump that we expand with the SDN technology to the WAN domain. Then the expanding accelerates in the following years. We can see from this picture expand to the first area we call multiple cloud connect. We use SDN technology to control the connection to different public clouds, including AWS, Azure, our own cloud, enterprise cloud. And also, we deployed SDN technology as a very typical popular technology here. We introduced SD-WAN, with action, a very typical example of overlay networks. And after that, we introduced SDN to our transport network, another example for the underlay network. Last but not least, SD-WAN finally go into the customer domain. So we introduced SDN technology to control the customer LAN. So we call it kind of, SD-LAN, those kind of service that have provided to the customers. At the same time, we are experiencing a paradigm shift towards a hybrid ICT. So from this picture, you can see that the ICT infrastructure is no longer in a single domain. So people talk a lot about SD-WAN. The WAN network has already become hybrid. The customer will have more choice. They will have the choice of the MPLS network, but that's not the only choice. They can select internet or even LTE as their uplink. On the other side, the cloud also become hybrid. The multiple cloud topology has already become the de facto standard in the typical deployment scenario. So people are using multiple clouds, such as Amazon, Azure, or the combination of Azure and the Google Cloud and so on. And moreover, the acceleration, introduction of the SaaS application, including Office 365. Most of our customers talking about how to migrate the Office 365, how to optimize the access to Office 365. That will be a very huge change from the existing enterprise network. So this picture shows the current offering that we provided to our enterprise customer. You can see that in the middle, we provided the NFV platform. That is what I introduced last year. So we provide a variety kind of NFV services on the NFV platform in order to create value-added services to our customer. As I mentioned in the beginning, it can be web optimization as a service, firewall as a service, or SD-WAN gateway as a service. And also, one thing you should notice is that via the NFV POP, we provide private connection, to different cloud provider, including AWS, Azure. We provide a very flexible interconnection to the cloud providers via our POP. So which means that as long as you connect to our POP, it can be by many approach, like MPLS, Internet, LTE, and so on. Then you can have a very secure connection to the cloud service, or even the SaaS service, such as Office 365. And another point you should not neglect is that these POP are actually connected by our high-quality backbone. Just give you a very simple example for your understanding is that just imagine that you have a branch in Amsterdam. So your branch can connect to the closest POP. Then you can enjoy our backbone network. Then go to Japan, for example. You just imagine that you have a cloud infrastructure in Japan. Then by using our direct connection, direct peering with the cloud provider, you can simply connect to the cloud that's inside Japan. So that's a huge jump that I showed last year. So from the XEX to the VXF. So actually, this picture shows another view of the current offering that we provided to our enterprise user. So actually, it described a very similar view. Just like I mentioned, everything become hybrid. We have multiple choice of the uplink, like Internet, MPLS, LTE. And also, we have choice of different cloud provider, AWS, Azure, and Google Cloud. But one important thing actually behind this picture is that our VNF offering can be also deployed in a hybrid way, which means that in the location place, we have SD-WAN box, for example, our telco POP, or even the cloud. The customer can choose whenever they want to deploy their NFV service in this picture. So they can deploy SD-WAN onto the UCP box, or they can deploy firewall into our telco POP, or they can deploy other applications in the Amazon or Azure and so on. So let's change the view a little bit to the IoT domain. Let's look at what actually is happening inside the IoT domain. So far, the IoT network is a kind of two-level model. So, which means that most of the IoT data will send to the cloud without any processing on the edge. But we see a clear threat that the IoT infrastructure has already become a three-level model. So which means that partially the part of intelligence on the cloud has already migrated to the edge. And which means that the data processing will be done at the edge for some purpose, then the data will be sent to the cloud after the processing. So this is a very interesting migration actually happened in the IoT domain. So the benefits of such IoT edge solution is very obviously, as shown here. So actually people are not satisfied with the latency currently we provided, say, for example, 50 milliseconds anymore. So people actually are asking for more and more. People are asking for 10 milliseconds for latency or even less than 1 millisecond for latency. So such kind of IoT solution could be a very good solution that we can offer to the customer. And also showed on the right top of the picture is the autonomous control. So the people asking for a robust system, even in the case of some nature disaster, when the cloud is down, when the network is cut, their local system, they want their local system still running without problem. So such kind of local solution can just meet such requirement from those customers. And for sure, it's about the cost reduction of the WAN optimization. I think many people talk about edge computing in this conference as well. It makes sense that we send all of the data to the cloud, especially the data can be 4K, video streaming, so it actually uses lots of bandwidth. So why not doing some process on the edge side and filtering some data and send only the critical data to the cloud? So this is another requirement actually we heard from our end customer. Last but not least is the privacy protection. Actually, this is a very interesting use requirement from most of our manufacturing users. So sometimes people do not believe public cloud. They want to keep all the data in their own control. So this is the solution that those kinds of customers are looking for. Okay, another use case is coming on the stage, which is local 5G. So what we see, let's take an example of the factory use case. What kind of challenge we see so far is that the currently wireline IoT network inside the factory actually make the IoT facility a big mess. And this hinder greatly the digital transformation of those factory customer. So by utilizing the local 5G technology, so it really helps those customers to realize the digital transformation by using mobile networks, and also the infrastructure that provided by the local 5G can provide a kind of computing infrastructure in order to manage those kind of local edge application in a very organized way. So the people can manage those applications in one site. Even they can still get very good latency because they are on site. And I just talked about the use case about smart factory, but I think the application of local 5G can be expanded to many domains. So just like I show here as an example, it can be in the sports industry. It can help the positioning, analysis, strategy planning, and also it can help the retail to do some distribution, marketing. So the use case here will be a very potential a benefit to a variety of kind of customers behind. So let's go back to the picture again. So I want to show you what actually changed so far in the past 1 year. So just give you some keyword here. So the 5G is on the stage. The VNF becomes CNF. And instead of the network function, we provide IoT and AI functions. So that's the big change. And these changes is really the enabler for us to transfer, to do the transformation from the VXF, SDX that people talk here to the Smart X world. So we talked a lot about concept. So I would like to share with you a very concrete example that we are working on, which we call next generation UCP. This is just one of the enabler technology for us to pursue Smart X dream. So we can see that this UCP platform is a platform to support containerized network function and the IoT and AI functions. So this platform is totally container-based. It will support container function, and it will also support well for the container networking. And similar to many traditional UCP solutions, we also support zero-touch provisioning, which means that as long as you connect your UCP platform to any of your like internet or MPLS network, the zero-touch provisioning will happen, and all the container and the container networking configuration will be downloaded automatically and will be applied automatically, and the services will be provisioned automatically by the zero-touch provisioning way. And last but not least, we also provide some basic IoT gateway functions, like messaging protocols, device shadow, to control the IoT devices in a very well manner. Last but not least, we provide a connection to different kind of cloud. So which means that this is actually a very important point. This enables the user to select the data destination. The people can select, for example, Amazon for their data to send to, or they can select Azure to send their IoT data. Just give you two quick use cases here. The first is zero-touch provisioning. Actually, what here we provide here is just a very simple example. Like, first of all, as I showed here, the IoT data will be collected on some kind of sensor. Then it will be sent to the UCP box via private LTE at current moment. And in the future, we will provide 5G, and it will be sent via the 5G technology. Then on the box, we provide container-based EPC solution and container-based AI solution like TensorFlow module, so that we can do some kind of analysis outside the UCP. And after the analysis, we will send the result to the cloud. Just give you a simple example. We can send the data to our NTT communication provided Things Cloud to do some visualization. So this is actually the function that our customer is asking for. But how could we realize such function? So it can be actually implemented in a zero-touch way, as I showed in the gray button here. So first of all, before we provide the service, we can create a service template. So the customer can define what kind of services they want, how to connect those services in a kind of template. Then before we send the box to the customer, so we will do some basic kitting work, for example, to configure the IP address on site, gateway, serial number, and so on. So after the customer received the box, as long as they connect to the internet, then the zero touch will be triggered automatically, which means that the container and the configuration that relates to the container will be downloaded automatically from our cloud and to the UCP box, and the service is provided in a very quickly way. Another use case here that I want to share with you is the intelligent IoT device control. So what we actually want to achieve here is to control the IoT device locally. So just give you some simple use cases here. Just first of all, the first button here is the startup of a certain IoT device. So we implemented a kind of device shadow function in our UCP so that the device shadow will manage the status of the IoT device. So when the IoT device is up, it will do a synchronization with the UCP box and get the latest status. So you can just follow the orders from the UCP to configure their own state. And also, we can have a local management applications. From that, we can control the sensor devices as well from the messaging protocols that we provided by our UCP solution. And also, as showed here, we implemented a local shadow and the remote shadow at the same time. So which means that the status of the UCP device is always synchronized with the cloud side. So just imagine that one link is cut, So the status of the UCP, the things will still buffered in the UCP device. So it can still use the buffer device to manage, to control the IoT device. But after the recovery of the one link, and automatically the status of those IoT devices will be automatically synced to the cloud. So in this way, no matter whether the one link is cut or not, always can be synchronized in an automatic way. Last but not least is IoT device control application, which can even locate in a remote place. We can control the device from the cloud. No matter if the one link is up and down, all the status and all the service order will be buffered. And as long as the one link is connected again, then the service order will download to the IoT device automatically. I think that's what I can share with you today. And I think I'm just in time. And if you have any questions, so you can ask now or you can ask later. Any question or comments? No? Great. Thank you for your time. And I wish I can see you in the next year. Bye-bye.